Hello friends and welcome at my channel. Today I would like to show you how to compute the derivative of the cosine of x using the first principle and maybe also as the second guess the chain rule. So let us start with f of x being equal to the cosine of x, and the first principle means that we are having a limit h towards 0. We are having cosine of xo plus h minus cosine of xo, and we are dividing it by h. We have a limit h towards 0. Now we're using once again additional theorems, so we're having cosine of the first angle times the cosine of the second minus the sine of the first times the sine of the second, and still minus the cosine of xo. We divide it all by h. So now, as you can see, we are having cosine of xo here and there, so we're just taking it outside of the parentheses, and we are getting cosine of h minus 1 minus sine of xo times sine of h divided over h only. And that would be a limit h towards 0. And, well, we just split this limit into two parts. So we have the cosine of xo times the cosine of h minus 1 divided by h minus sine of xo times the sine of h divided by h again. Now we have a limit of the difference, and we can produce a difference of limits if we would know that those two limits do really exist. So let us put it here once again, the question mark. We don't know it yet. So we have a limit h towards 0 of the cosine of xo times the cosine of h minus 1 divided over h. That's the first one. And then also minus the limit h towards 0 sine of xo sine of h divided over h. And now, as you can see, I can actually immediately erase the question mark, because this is a constant that we can take outside of the limit. It's not dependent on h. This constant is not dependent on h either, so we are taking cosine of xo outside of the limit. Then we have a limit h towards 0 of cosine of h minus 1 divided by h, but this limit is familiar. In the last video, where we produced the derivative of the sine, we proved that this limit is 0. I'll link it right here. And we're doing the same with the second limit, so we're keeping the sine of xo outside of the limit. We have a limit h towards 0 of sine of h divided over h. This limit we are also familiar with. This is 1. So this gives us 0, and that gives us 1. So this is why we're getting to minus sine of xo. That's the result. And the question mark can be erased. All right, so that's the first principle. And how can we do it with the chain rule? Well, if you remember the cosine of alpha, this is the sine of 90 minus alpha, which means if I would like to produce derivative of f of x equals to cosine of x, I could rewrite as sine of 90 minus x instead of that. So the first derivative is the same as having the first derivative of this expression, which is a composed function. It consists of two functions. The first one is 90 minus x, and the second is the sine of this value. So we have the derivative of the sine, which we know is cosine, so cosine of 90 minus x, and now the inner derivative of 90 minus x is minus 1. Cosine of 90 minus x, by the same principle, is just a sine times minus 1. We get minus sine of x. And that's it. All right? Thanks for watching, and see you guys in the next video. Bye-bye.